In this video, we will discuss that how can we take the Fourier transform of impulse function. We already know that the Fourier transform of a signal is given by using this equation, like x of omega is equals to integration from minus infinity to infinity x of t e raised to power minus j omega t dt. And if the function is impulse function, so it means that we know that the value of the impulse function is only when t is equals to 0. So the function is only have a value at t is equals to 0, and the function is 0 everywhere else. So similarly, we can write x of t with the delta t, that is the impulse function, and you are taking the Fourier transform of delta omega, which will be equals to delta t. So that if you take the Fourier transform of delta t, then it will be equals to delta omega. So that is the function in frequency domain, and delta t e raised to power minus j omega t dt. So you know that the function only have a value of 1 at t is equals to 0, and everywhere else it is 0. So that is why you don't need to take the integration at every point, because the function have a 0 value on the negative x-axis, like from 0 to minus infinity. Similarly, from 0 to plus infinity, the function have a 0 value. The function only have a value 1 when the value of t is equals to 0. So then you can simply write the integration with this formula, that delta t e raised to power minus j omega t when t is equals to 0. So then you just insert the value of t is equals to 0 in this equation, then delta t is equals to 0 e raised to power minus j omega 0. So delta t is equals to 0, then the value is 1. So e raised to power 0, then you know the power 0, then the answer will be 1. So 1 multiplied by 1, the answer is 1. So it shows that any transform of impulse function is equals to 1. Similarly, you can calculate the Fourier transform of a DC signal. So suppose we have a DC signal whose amplitude is given by this line, which is A. So that is unknown value. So you can say it that the DC signal is a positive DC signal and it has a no frequency. So we need to first consider that the conditions, that how can we take the Fourier transform, either the function fulfill those conditions that we have already displayed in our previous lecture. So we can see that if the integration of that function is finite, give you the finite value, like the integration of f of t, as you can say, so f of t is a, so if you take the integration of a, it will give you a, and then t lower limit and then upper limit. So if you insert the lower limit and the upper limit, like lower limit minus lower limit, which is equals to a infinity plus infinity. So infinity plus infinity to infinity, and 2 infinity is equals to 2a infinity. So infinity multiplied by anything, the answer is infinity. It means that we are not getting any finite value, which is the first condition of the Fourier transform. So it shows that DC signal is not integrable, because the value of the integration is infinity. So then we cannot transform the signal into a frequency domain.